Hello everybody. I'm going to show you some electronic testing tools. Okay, this is going to go along with the lecture that I gave you today. All right, so basically we have a very basic system. Okay, we got a light with power and ground going to it. Okay, so we are going to start with the beginning. In order for anything to work, we need a difference in voltages. Okay, so we got 12 volts here, 0 volts here. As a result, our circuit operates. Okay. We're going to take a voltmeter. Actually, before we go to a voltmeter, we're going to start with the basic tool that I showed you before, which is the test light. Right, so it's got a clip, and you have your light, and basically one end goes to one side and will detect the other. So I'll give you an example. Okay, you can turn it on. I'm going to take this little clip in the bottom here so I can connect my clip to it, and that's ground. That's 0 volts. Right, you see no light, but if I touch it up here, which is out of frame, okay, you see it lights up green. Right, so that's detecting the presence of 12 volts because I'm connected to 0 volts down at the bottom. If I put it in here, okay, 12 volts. If I go to this side, no volts. Right? Now I can do the same thing if I plug it in up top. Right? Now it's hooked to 12 volts. And now if I put it in, no light because it's 12 volts. But if I connect it to ground, it'll detect ground. Essentially, this is a light bulb like that. It's an LED, and it needs power and ground to make it light. So we created our own circuit with power and ground. No difference than what's feeding this light bulb. Okay, so I'm going to put this aside, but this is a basic non-powered test light. Let's talk about a powered test light. Okay, for this I'm going to put a pigtail on both, and this is called a power probe. Okay, it's got two LEDs. It's got an LED here and an LED here. It's got lights at the top, and it's got a rocker. One of them give in one direction power, in one direction ground. It also has a clip if you wanted to maintain whatever it is on there. You can lock the toggle switch in position. Right, so we connect this to power and ground. We got two clips, power and ground. And you can see now how about if we connect it properly? Power and ground. Okay, I'm leaving a blooper reel in here with it. Okay, so you can see we're lit up now. and you can see this little LED. If I point it this way, red light, you can't see it because it's bleaching out the color, but that's the red light up here, and listen to the sound. That's power, green light, ground. Okay, so if I put it in the top here, it's indicating power with a red light. And if I put it down here, it's giving us ground with a green light. Now let's say I disconnect power. Well, now I can take this. Actually, wait a second. I need the test light to still be hooked up. Okay, ground is still connected to the bulb. There's our positive side that would normally go up top there, but now if I take it and I force it to power, I can now operate the light. Same thing goes with ground. We disconnect it. I can switch it to green for ground and supply ground, right? That's why I say it's a very cool tool, because I can command power and ground at any given time. The magic is being able to blow stuff up at will. Make the magic smoke come out of things. Okay, so you saw non-powered test lights and you saw powered test lights. So now we're going to go to our meter. You saw them talk about this on the video. You have volts, ohms, and diodes in this position. The black goes to common, and it's always there. This is milliamps, and this is amps. You never move the black lead. For all general purposes, you will not use this one. You will only use this one. If we look around the dials, we have alternating current voltage, AC voltage, direct current, DC voltage, DC millivolts, ohms and continuity. This is for checking diodes. This is milliamps and amps, DC, well, AC and DC. The yellow button is a shift key. So if I wanted DC amperage, I would turn it to here and hit this button, and it would switch us to DC. And I'll show you how we do that along the way. You got your leads. Okay, so at the very least, we're going to check voltage. So we're going to move this to volts DC, because this is DC. I'll even hit this to give you a light so you can see. And if I hook this to ground and I hook this to power, we show battery power. All right, the difference, remember I was talking about the difference between 2 points. This is 0 and that's 12. It's a little below because the light bulb is sucking up some of the voltage there. All right, so if I check here, right, still got voltage. If I go here, now it's virtually 0. What that's measuring now is the voltage drop in this wire. Right, we have a 34 millivolt difference in this wire right here. That's what it's measuring. If we go right here, naturally that's 0. Now if we want to check voltage drop of this other wire, you see we have a 13 millivolt difference up there. That's the resistance in the wire using up some of the voltage. Now if you notice, if I do that, you see that we got a voltage there. Well, the light bulb's getting voltage and the meter's getting voltage. The meter has its own ground and its own power. Thus, this is hooked up in parallel. When we're measuring voltage, we hook the meter up in parallel. And that's what it means. We have another branch. The power comes in, it's got two different pathways to ground, and that's a parallel circuit. Okay? So, you just saw us check for voltage. You also saw us check for voltage drop. Now we want to talk about amperage. Okay? So what we're going to do is we're going to turn our power off. We're going to switch our dial. Now if this thing ever beeps at you, your leads are in the wrong position for what you chose. We're going to move it to amps, but notice it says AC. We have to hit the yellow button to switch it to DC. We have to move our red to the amp jack. And now what we need to do is we have to hook it in series. In series means it's in the single pathway from power to ground. You break it open, you install it. And I can do it anywhere because it's going to be the same. Whatever's coming in here is what's leaving here. So I can hook this up anywhere and get my values. So I'm going to open it up here. The red lead goes to the most positive side. The black lead goes to the most negative side. And when I turn it on, we've got our amperage, 1.96 amps. Now notice it's changing. It's because the resistance of the light bulb is changing now that it's heating up. Okay? So that's what it is here. If I hook this up and I disconnect it up here, most positive, most negative. Same amperage. If I go over here and I break it open over here, right, most positive, most negative, same thing. If I disconnect it down here, most positive side, most negative side, same thing. Right? You're seeing it change a little bit just from our little varying connections there. Okay? So that's amperage. Now we said before, what if we had too many amps to put through the meter? Because if you remember, the meter is only good for 10 amps. Well, this is a mini amp clamp. It's an inductive amp clamp. To use this, we install this in volts. We put this in ground and we set it for millivolts. Right? We turn it on and we have different scales. So you can see we have a 20 amp and a 40 amp. We're going to go in 20 amp because this isn't that much. Notice we have a reading here. Oh, let me get the light going. I'm going to hit the 0 button and you'll see the meter go to 0. Right? Now if I put it around, it's picking up the magnetic field that's running through the wire. That's about what we measured before. So it's pretty accurate. Right? So that's called an inductive clamp. Now we can measure, this clamp is good for measuring up to 40 amps. More than that, we have to have a heavier duty clamp. All right, so now we have another kind of current we talked about. Right, we talked about AC current. So we're going to put this back in volts, and we're going to take this one and you're going to hook this back to common. And we're going to set it for AC voltage. Now up top here, this is AC 12 volts right here. If we stuck it in the outlet in the two little slots, we'd see 122 volts AC. But if I put this up here, right, we got 14 volts AC. If I switch them, what do you think? It's going to be negative? Nope, same thing. Because it's alternating current. It's flipping back and forth and back and forth and back and forth. Okay? So now we got one more thing. We have resistance. So I'm going to shut this off. And I'm going to use a physical resistor. Right? We're not connected to it. We set our meter for ohms. Now this is what I was talking about before. If I put them together, you can see we have 0.1 ohms of resistance in the leads. Right? This is what I was talking about. See that relative delta button? See it go to 0? Now our numbers are tilted to make up for that difference. And this way we get a true reading. Now what's going to happen is if I try to measure something really big, this is going to go OL because we did that. Because it's only meant to if we're dealing with tiny amounts of resistance. Right? So I'm going to recycle it and I'm not going to do anything with that. One lead goes on one side. And there's the resistance of that resistor. 99.4 ohms. Right? We've got another one here. $100 ohms. Oh, and I'm sorry. That's 10K, 10,000. So K is 3 decimal places. We'd move this over 3, and that would give us 10,000. If I move it here, .987 K. Right? So 3 decimal places. 1, 2, 3 to the right gives us 986. Across this other one, 99. Right? So this thing's going to auto range. It's going to automatically put us where we need it to be. Now if I hit the range button, you'll see I'm moving the decimal place around. Right? So all that did was just keep moving that decimal place to a different position. If we want to check the resistance of a light bulb with it off, we can hook this up with it disconnected from power and isolated, and we can see we measure 4.6 ohms. Now what happens is, if you remember, resistance goes up with temperature. We'd see that when it was actually operating increases in resistance. Okay, so I want to show you one more thing, because you might have to do this one day. Right? Notice on a fuse, trying to get it in frame, right? This is a fuse, and we have those 2 little dots up top. I'm going to pull it out so I can show you. See the element inside, and you can see those 2 little dots. Power comes in one, jumps this little bridge and out the other side and down here. So in order to test this, we want to see power on both of these. And if I take this and I put it back in, and I put it in line with our light bulb here. We put it down here so we can test it. Right, one side is now going into the switch, and the other one's going up to power. If we wanted to check, first of all, for power at the fuse, we set it to volts DC. And we can see, I unplugged it. Blooper reel. It's midnight I'm taking this, just so you know. Ah, stop it. Okay, we hooked at the ground. We check. See what I do for you people? We touch the one little dot. You see it's got 12 volts on it. We touch the other little dot. 12 volts. So power is coming into the fuse, coming across, and coming out. Now, if we want to check to see if a fuse is good, let's say that we couldn't tell. Switch it to ohm, pull the fuse out, and what should happen is you should have no resistance in a fuse. I'm going to try to do this now. This should be comical. Alright, and I'm checking the two blades, and that means that there's very little resistance. The only resistance is in the leads. We have continuity through. And now let me show you continuity. I hit this little continuity button, and now it's going to measure almost 0 ohms. It's going to beep. Okay, so that indicates we have a good connection between 2 points. Anywhere we did that, it should do that same thing. Again, checking continuity, we cannot have power in the circuit because it's measuring resistance. Alright, so I'm hoping I gave you enough to work with for what you were taught today. Alright? Any questions, post in discussion, and I'm happy to clear up for you. Alright, sounds good? Okay, you'll see this tomorrow.